Hi there, it's Rob from Auburn Amplifiers and Queen Bitch Amplifiers with another under the hood look at the science and technology of tube guitar amplifiers. And this video is going to be an addendum to an earlier one about output transformers that came about because of some questions that I was asked after that video was posted. Now, output transformers, if you haven't seen the other video, don't sweat it. I can summarize it by saying that output transformers are important because they are the lens through which the output stage sees the load. In other words, how the tube or tubes at the output of the amplifier see the speakers. And that's important because the tubes will behave differently, and most importantly, they'll have a different distortion characteristic depending on how heavily or how lightly they're loaded. A heavy load is a smaller impedance, and a lighter load is a larger impedance. You can see this sort of data on tube data sheets if you dig around, but the details of what's going on are not often shown there. And if you're just cloning an amplifier and following the impedances of transformers that were traditionally used by manufacturers, you're missing out on an opportunity to really make your amplifier suit what you're after tone-wise and power-wise. Manufacturers were constrained by things that shouldn't affect you if you're building an amplifier one-off just for yourself. They were concerned about cost and availability and the inventory they had on hand, and also whether a transformer they chose could be used in other models that they made. So you don't have to worry about that stuff. You can tweak your amp to get the sound you want. And there's a widespread misunderstanding about the importance of the loading on the output tubes, and that's because the tubes will operate into a wide range of loads, almost over a 2-to-1 range for a lot of output tubes. And if they make a reasonable amount of power, then people say, well, that's cool, it's working. But there's more to it than that. If you heavily load a tube, you're going to see more second harmonic distortion, that's the octave distortion. And if you lightly load a tube or tubes, you're going to see more third harmonic creeping up. Now, if that doesn't mean anything to you in terms of sound, think about the sound of a single-ended amp, like a Fender Champ or something. So if that clangy, loud, harmonic-rich sound is what you're after, then maybe a lightly loaded output tube is going to be what you should go for in your own build. On the other side, if you're more of a jazz player and you don't like a lot of added harmonics, maybe just a second harmonic to give it a bit of warmth and fullness is what you want, then you might want a more heavily loaded tube. Okay, so fine, you know what your objectives are, but there aren't a lot of different types of output transformers out there. So how do you tweak for the situation you want? Well, one question was, if output transformers in tube amps aren't built with the same level of care and engineering as those in high-end hi-fi amplifiers, then can you just repurpose a power transformer? And the answer is yeah, you can. It will work. It might sound okay. The output transformers in a lot of traditional tube amps were not that much fancier than filament transformers. So yeah, you can do that, and we'll crunch the numbers for that in a minute. The other question that came up was, well, how can I tweak a transformer? I'm not going to go and wind a new one unless you're really enterprising. And as I've mentioned, there aren't a lot of choices out there. So what if you want to put a 5K load on a pair of 6L6s and hear what that sounds like? Well, because the transformer is a load that magnifies the impedance of the speakers to the output tubes in a very linear fashion, then you can change the load and therefore change the load that the tubes are seeing. I mean, change the load on the secondary, and you've changed the load on the primary. And the way you can change the load on the secondary is, well, with speakers, of course, but that's very quantized. You can only do 4, 8, 16, and combinations of series and parallel, which get a little tricky. But what you can do is add resistance. And that is a very slick way to change the load that the tubes are seeing without a huge sacrifice in the amount of volume, which you don't really care about because, dirty little secret, there's not a huge amount of difference in volume between a 30 and 40 watt amplifier. Okay, so let's say you've got a transformer that has a 6.4K primary when the secondary is loaded with 8 ohms. That's fairly standard. But you want something with a lower primary impedance, say 5K. We're going to do a little number crunching here, but first, the concept. if you want a heavier load on the primary, you have to put a heavier load on the secondary. And it has to be proportionally heavy to the change you want to make on the primary. So let's crunch those numbers. So you've got your 6.4K transformer and you want a 5K transformer. Well, what's the ratio of 5K to 6.4K? We crunch that and it is 0.78. All right, so we know we need to increase the load on the secondary by that same amount. We want 0.78 of 8 ohms, and that comes out to 6.25 ohms. Okay, now how do we know how much resistance to add across an 8 ohm speaker to turn it into a 6.25 ohm speaker? Some of you know this already. It's the reciprocal sum rule for adding resistances. And I'll probably do a separate video on that. It's a little geeky for right now, but take my word for it. Just look at this here. If you take a 1 over 6.25 and subtract 1 over 8 from that, you end up with 1 over 28.6. And so that is the resistance we need to add across an 8 ohm speaker to end up with a 6.25 ohm speaker. Of course, there's no such thing as a 28.6 ohm resistor, and we don't care if there is, because 27 is close enough. The speaker isn't 8 ohms anyway, not in all frequencies. So we are going to look for a 27 ohm speaker. How much power does it have to handle? Look at the resistance ratio between the resistor we're adding and the speaker itself. The resistor is about 3 times the resistance of the speaker, so it's going to be absorbing about 1/3 of the power that the speaker is, or 1/4 of the total power that the amp is putting out. So we're looking, if your amp is 40 watts, we're looking for a resistor that can handle at least 10 watts. So 27 ohm 10 watt resistor, I'm sure you've got one kicking around in the drawer. You put that across the speaker and voila, your 6.4K output transformer is now a 5K output transformer. You've sacrificed some power, but in the real world we generally don't care about that. It's not a lot of power. And unless you're a marketing manager for a major amp manufacturer, you know that there isn't a huge volume difference between a 40 watt amp and a 50 watt amp. You probably can't even tell into the same speaker. So, going the other way, let's say you've got that same 6.4K transformer and you want a transformer with an 8K primary impedance. Okay, we likewise look at the ratio between 8K and 6.4K, and we see it's 1.25. So we need to get a load on the secondary of the transformer that is 1.25 times lighter than 8 ohms in order to lighten the load on the primary by the same ratio. So 1.25 times an 8 ohm speaker is nice and easy 10 ohms. So we want to know how to turn your 8 ohm speaker into a 10 ohm speaker. Piece of cake, put a 2 ohm resistor in series with it. That's a nice off-the-shelf value. Again, how much power? Well, look at it. It's a 2 ohm resistor in series with an 8 ohm speaker. So 1/5 of the power from the amplifier is being turned into heat by the resistor, so you need a resistor that's rated for at least 1/5 of the maximum power output of your amplifier. Et voila. And this technique allows you to experiment with different loads on the output tubes and hear the effects of the load. And then once you find something you like, you can go out looking for a transformer that will do exactly that without sacrificing power to the resistors, if you care about that. If not, you can just use parts from your junk box and tweak an amp this way. And I mentioned earlier that this is a result of someone's question. Can you use just a regular filament transformer, like a transformer that's designed to make a DC power supply, for example, as an output transformer? Well, you can. You can. They're designed for efficiencies to a certain degree. They are not. They're meant to pass 60 hertz, which is lower than the lowest note on a guitar. They're not meant to pass high frequencies, but they will. They will go high enough for a guitar for sure. And as I mentioned earlier, there's nothing particularly fancy about the design of output transformers that were used in factory mass-produced amplifiers. There wouldn't be. They just wanted them to make power and to sound reasonably good and to cost a reasonable amount. So there was nothing fancy about those output transformers. So digging around your junk box, if you've got a filament transformer, this is how you figure out whether it's going to be suitable as an output transformer, at least for experimental purposes. Let's say you've got a transformer that's got two 120 volt primaries and a 12 volt secondary. That's pretty standard. What you can do is stack those primaries and put them in series, in other words, and where they join, that becomes your center tap. That is your primary, and the secondary is 12 volts. So now you have a transformer that's 240 to 12 volts. Well, that's a voltage ratio of 20 to 1. To get the impedance ratio, you square that. So you have an impedance ratio of 400 to 1. So now you know if you put an 8 ohm load on the secondary of that transformer, you multiply that by 400, and that's the load on the tubes, the primary, and that's 3,200 ohms. Well, that is a really standard load for a pair of EL84s, for example, 3.2K. Or if you want, you stick a 16 ohm load on that same transformer, and voila, you've got 6.4K on the primary. And that's nice for doing an AC15 type of build. Okay, well, I hope that wasn't too geeky or propeller head. It's not intended to be confusing. It's intended to clarify some things that are rather important about making your build sound the way you want it to, and not falling into the traps of just cloning existing factory designs from 30, 40, 50 years ago, because you're not held to the constraints that they were. You can actually make an amplifier whose primary goal is to last a long, long time and to sound exactly the way you want it to. And that's what we're trying to do. Then, in order to find exactly the sound you want, you sometimes need to experiment with the loads on the output tubes, and I've just described two ways that you can do that. All right, anyway, this is Rob from Auburn Amplifiers and Queen Bitch Amplifiers, hoping that you have a day full of music.